All right, today's lesson we'll be talking about visual scanning and collision avoidance. Now, the goal of this lesson is that you learn ACS knowledge of visual scanning and collision avoidance, but not only that you learn ACS knowledge of visual scanning and collision avoidance, but that you also develop some safe habits that you can bring with you anywhere you go flying. It's extremely important that you have an intrinsic understanding of visual scanning and collision avoidance because you could need that at any time. For example, I was flying, doing some stage check prep, some check ride prep back during my private at my 61 school. And I was going to an airport close by, and they have parachute jumper activity all day, so we were dodging skydivers and stuff like that. And then we finally head back to our home airport, trying to relax and calm down because we just dealt with that stressful situation. And then we get to going back to our home airport. We hear bank right, obviously not for us because we didn't hear the tail number. We haven't even called in yet. Then we hear bank right immediately and they had a tail number at this time because we were finally in range. And then I remarked to my instructor, I was like, dang, sounds like somebody's not listening to the tower today. And at that time, we both noticed a yellow object off our front, but we couldn't tell what it was. It might have just been some stuff on the windscreen and stuff like that. And then we call up, and tower immediately cuts us off and says, 526 Delta Sierra, bank right immediately, which was us. So we bank right, and then half a mile away, I see another aircraft, yellow, coming the exact opposite way at the exact same altitude. And, you know, if it weren't for tower and if it weren't for us, we might have actually been in a head-on collision that day. So you can see the extreme importance that there is with visual scanning. Now, let me ask you, where does visual scanning intrinsically start?
I guess I would say it starts as soon as you take off.
It's a good idea, but I mean on a more deeper level. What I mean is visual scanning actually starts with your eye. And there are two parts of the eye that I want you to know about specifically. And there are two photoreceptive cells that I want you to know about in order to understand what you're doing whenever you're scanning. So we have this massive cord off the back of the eye. This is the back of the eye. And that's the optic nerve. We have these squiggly lines, which is your retina. And then we have this small depression in the back of your eye, which is the fovea. The retina is filled in exclusively with rods, which is one of the photoreceptive cells that I want you to know about. And the fovea is exclusively filled with cones. And that's the other photoreceptive cell that I want you to know about. And I want you to know about this because it plays into how we see. You get a direct visual contact from the center of your vision straight back to your fovea. And that's why you can see with the center of your vision during the day. And you can remember that you're using cones during the day because cones are for color. So you're using your fovea for your daytime vision and your retina for your nighttime vision. So each one correlates with each other. Retina, rods, night, fovea, cones, day. So that is extremely important because it also ties into the types of visions that you need to understand. You have a photopic vision, and a photopic vision is using your fovea with cones during the day. Whereas scotopic vision, you're using your retina, using your rods at night. And that is extremely low-level light scenarios, like outside with no moonlight. And then you have your mesopic range, which is using both your rods and your cones. And you can remember that because you won't miss a thing. In the mesopic range, there are a couple of things that you need to know about it. A, that you're using both rods and cones, and B, that there might be a blue light shift. You can think about it, you're more in your mesopic range whenever you're about to go to bed, but the bathroom light's still on. So it's really dim light scenarios. And you'll see that blue light shift, and that's where you can really know that you're in the mesopic range. And your visual acuity in the mesopic range might change based on how much light there is and whether or not the object's in the center of your vision or in the sides of your vision. Now, see and avoid is a simple concept, however, it's an extremely important concept that you know. See and avoid, the FAA deems that see and avoid always falls on the operator of the aircraft no matter what the condition of the day is. It will always fall on either the SIC or me as your safety pilot or you as the PIC. It will always fall on one of us, and both of us realistically, to always stay away from other traffic. Now, how are you supposed to follow through with your duty of see and avoid if you don't know how to properly visual scan? Well, that leads us into visual scanning and the basic visual scans that we have. Our eyes have evolved over time to pick up motion. We are very, very keen to pick up motion. And we also have a simplistic way of scanning. you can divide the windscreen into small sections, 10 degrees at a time, scanning each 10-degree segment for about 1 second. Now that you know about some parts of the eye and our basic scanning, do you think there's a difference between day and night scanning?
I'm not really sure.
Okay. Well, there is actually a bit of a difference in our day and night scanning. During the day, since we can use our fovea, we can scan at the center of each square for that 1 second interval and use the center of our vision to pick up that motion. However, at night, since we can't use our fovea, we're actually scanning with a peripheral vision. So whenever we scan each section, you're scanning with your peripheral vision around there, and you're looking for the motion of light as you scan. Now, for our visual scanning, it depends on the pilot. Personally, I use a checkerboard pattern to scan. However, some people use columns or rows to, figure out how to find traffic. Now, there are some hazards associated with the aircraft that we fly, specifically the way that the aircraft is set up. For example, here at Liberty University, we fly a high-wing setup aircraft, which means that we have blind spots above us. We set up the aircraft like this. We have blind spots above us. However, other aircraft, maybe a low-wing aircraft, will have blind spots below it. So we need to be aware of the blind spots that are above and below us depending on the aircraft that we're flying. Also, with a Cessna, we have small blind spots such as struts, so we can't see out the side of the aircraft. And also, some aircraft may have blind spots on either the windshield or other spots around the aircraft, so we just need to be aware of those. Now that you know about some of the stuff that might be reducing that risk, there's also some stuff that may be happening behind us. If we're in airspaces with faster traffic or anything like that, we could have aircraft come up behind us. So we just need to be aware of the airspace that we're in and what could be around us, as they could be much faster than us. Now, AIM 8-1-8 specifically tells us that we need to be wary of airways around VORs, and especially airport surface areas. As you know, that's where aircraft tend to cluster. Remember, most collisions actually happen in good weather in radar environments. Just because you're in a radar environment and just because it's good weather doesn't mean that you can relax. It's still a time for you to be on your game looking for other traffic. We also need to be aware of traffic patterns. A lot of people have lost their lives in traffic patterns because of just how busy they are. For example, if we're on final right here, there could be somebody coming up above us like this, or there could be somebody who's coming on a much shallower final, and we could be, sandwiched in between them. At this point, I would show a video. However, every time I turn my camera around to try and show the video, it just looks weird. So watch the video on the lesson plan that I turned in. It's terrifying. Now, what are some other considerations that we could have that could mitigate our risk when we're looking for other traffic?
I guess just focusing.
Focusing is a really good one, but there are some other things that we could also do. One thing that we can do is to ensure that our windshield is clean. For example, if this is our windshield right here and we just see a bunch of bug guts, rocks, everything like that, you're never going to be able to notice this small little aircraft in the bottom right because you're distracted by all the other glaring objects on the windscreen. So make sure to clean your windscreen before each flight to remove any residue or rocks or anything that could have contaminated the windshield so that you have a better view. Now, you can also manage materials in the cockpit. We as pilots always have checklists, charts, manuals, everything right on our laps. So it's a lot of head down time. So one way that you can mitigate that is have a good working knowledge of the charts, checklists, manuals that you may be looking at so that you can keep a more heads-up time rather than heads-down time. You might also want to consider the conditions of the day. For example, even if it's clear, cloudy, or hazy, you may want to adjust your scanning so that you can properly visually scan with those conditions. You might also want to ask ATC with help trying to find other traffic. But we still need to understand, even if ATC is telling us exactly where traffic is, it still falls on us to see and avoid other traffic. Now, collision avoidance is an extremely important step of visual scanning. Imagine you're flying a plane back to Lynchburg and you see them coming on directly at you. You're not exactly sure their altitude is, but relatively your altitude going the exact opposite heading. What can you do?
I guess climb or descend.
Climb or descend is a really good idea. But you also need to consider your relation to the ground. If you're really low altitude, it's not like you can necessarily keep descending because you might have a controlled flight into terrain. But that actually cuts both ways. If you're at a high altitude, you may not be able to meet the climb gradient to get above the aircraft. So it's just dependent on where you are in relation to that aircraft and in relation to the ground. You might also want to consider our right-of-way rules. We have an acronym for that, and it's called E-BEGAR. And this E stands for emergency. Any aircraft that's in an emergency has the ultimate right of way. We also have balloon, which obviously hot air balloons are not very maneuverable, so they have the next most right of way. A glider, an airship, an airplane, and then we also have rotorcraft. Obviously, helicopters are very maneuverable, especially about the vertical axis, so they're at the lowest priority for right-of-way, whereas any aircraft that is in an emergency, they have the ultimate authority for right-of-way. Now, also, what happens if you're coming on straight on with another aircraft? If you're going this way, somebody else is coming this way. Well, we try to have a standardization of how to give way. We do this every day with our cars. We give way to the right. So we bring that over to this idea of collision avoidance in aviation, and we give way to the right. That gives us a standardization of which way to move, as well as the most distance between each aircraft. Now, we also have some tools that we can use to avoid other aircraft. We have TCAS, which is our Traffic Collision Avoidance System, and we also have ADSB. ADSB is our Automatic Dependent Surveillance Broadcast System. Now, the FAA deems that if you have TCAS or ADSB aboard your aircraft, you must run it at all times. We also can do one other thing, which is make sure our lights are on. Here at Liberty University, we specifically have recog lights so that there's a flashing light on either side of the wing, which makes us far more visible during both the day and night. Now, there are also illusions that you need to take in consideration. One of those illusions is a false horizon. Imagine you're flying and you don't necessarily see the horizon ahead of you, but you see something that's relatively stationary, it feels like. Say you use the ocean right here, and you're all the way out here trying to find the ocean. See right there. You're pointed right there as your horizon. However, as you navigate forward and forward to that ocean, that horizon now becomes steeper and steeper, so you might try to reorient yourself with that horizon, therefore putting you closer and closer to the ground, putting you more into an upset position. There's also another illusion that we have called autokinesis. Autokinesis says that whenever you're flying at night and you see a light off the distance or something like that, and you try to stare at it for a long time, since you can't stare at it with the center of your vision because you can't use your fovea at night, the light may start to appear to move, and you might start to reorient yourself with that light, which may put you into an upset position. So that's autokinesis. Now, in this lesson, you've been taught a proper way to visually scan for traffic and how to avoid those traffic. This is a very cut and dry rule that you must understand because visual scanning can be a life or death situation. So you must be able to take these situations that I've given you and all the stuff that I've been teaching you and be able to bring it into the aircraft at all times for any situation. Remember, our eyes are always tuned to find motion. So if you're using our small methodical 10-degree sections for 1 second, you'll be able to find the motion anywhere, wherever you are. And also be able to find any traffic in any situation that you may find. Do you have any questions for me?
No, I don't think so.
Perfect.
That's the end.